Hello guys, my name is Balakrishna Shrivastava and welcome to Code with PK. So in this video, we solve question 11 of ISC 2025 Computer Science Board Specimen Paper, which is this question. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. And I also teach coding in Hindi on my Code with BK Hindi channel. So solutions like these, concepts like these, you can find on my Hindi channel, Code with BK Hindi as well. Okay, please check it out. Alright then, so let's begin. So we have to solve question 11 of ISC 2025 Computer Science Board Specimen Paper. This is the question. It has two parts, right? We complete part 1 and then we complete part 2. Okay, so take a minute and give this a reading. Okay, so question 11, first part, is a very standard question where you have been given a class node that represents the node of a linked list. You have to either write an algorithm or a method. So method is a proper Java function that you have to write to search for a number from an existing linked list. The method declaration is as follows. So void find node. So this is the method to complete. Takes a node str, which is the reference to the first node in the linked list, the head of the linked list, and it takes an integer b. Let's make it b. Okay, making sure the name of the parameter is exactly the same. All right, and you have to search for this value in this linked list, and this is the class node that we have. It has the integer n to be stored and linked to the reference to the next link in this linked list. If this next link is null, it means we are at the last node of the linked list. So let me just explain this. So if I have, say, integers 2, 11, 4, 20 and 81 in a linked list, so this looks like something like this: 4, 20, 81 and null. Okay, so you can think of this arrow as link and these integers as n. Okay, you always store the first node of the linked list, the reference of the first node, into a variable which we have as str starting. Okay, because this is the starting point of the linked list. Okay, now if you say, if you store this in my str, okay, you can do that. Okay, but there is no way to go back to the previous nodes. We don't have a double link here. This is not there. Okay, so you will end up losing these two nodes and this will be the only linked list left. Okay, so str, the reference to the node we store, is always the first node in the linked list. Okay, you have to search for a value, say b, it is the okay. All right, so all you have to do is iterate from left to right and check if any of these integers matches the value b. Okay, for that, what we do, we take another node type reference, say t, and set it to start. Okay, temp or some other variable. Okay, so now t points here and we move forward as long as we don't find b a match or we are at the end of the linked list. Okay, so t is here, then t goes to next node, then t goes to next node, t goes to next node, t goes to next node, t goes to next node. Okay, so how do you go to next node? You do t equal to t dot link. Okay, this statement just means that currently I am pointing at this reference. Make me go to the reference, make me go to the object which is pointed by this link, which is basically the next node in the linked list. Okay, and that's how we keep traversing forward. If at any point t dot b equal to, t dot n, right, this is the variable n, equal to b, then we have found the value b. Okay, and when t is null, okay, so t starts here, non-null, 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 null. When t goes to null, okay, we are at the end of the linked list. Okay, very simple standard way. Okay, so I'm going to code this now. Okay, a flag to store true, false. Okay, based on the fact that we are able to find the value b in the linked list or not. So boolean found is set to false to begin with. Okay, variable to iterate over the linked list. Okay, I'll say node current, or you can say t as well. I'll take, let's say t. Okay, starting at the head. Okay, while t is not equal to null, as long as there is a node. Okay, if this node has the value we are looking for, okay, that is if t dot n double equal to B, we set found to true. Okay, and you can break or you cannot break, depends upon you, right? Because once found is set to true, it cannot be set to false again. Okay, so I will break. You can choose not to break as well. Okay, it will just keep moving forward till it finds till it goes to the end of the linked list. Okay, and then we say t equal to t dot link. Okay, so after this loop terminates, your found will be either false or true. It will be true if this condition is true. This condition is true if there is some node where the value integer n equal to b, which is what we are looking for. That sets found to true. If this condition is never true, the variable t keeps traversing the linked list, goes to the end, goes null. All right, this loop terminates and found remains false. Okay, print message if the search value was found or not. So if found, okay, what does the requirement say? Search for one by existing linked list. So sys out number plus b was found in the linked list. Okay, else number b was not found in the linked list if found is false. Else if found is false. All right. Okay, and that's all the code that you need. Okay, all right, so I have written other functions to create a linked list, print a linked list, and test. This is me creating a linked list. Okay, I have a reference to head and tail, and I keep adding to the end of the tail. Once I create my first node, which will be my head, I don't change my head. Okay, so only once I create the head, and then I keep updating the tail. All right, finally return the head, because we always keep a reference to the first node of the linked list, which is the head of the linked list. This means variable number of arguments. Okay, so you can iterate it using a for each loop as an array. All right, this means you can pass any number of integers, which I am doing here. Okay, so I am passing these many integers. Say I remove this, it is still fine. I remove this, still fine. Okay, I can pass any number of integers here. That's what these triple dots mean. Okay, and then I have another method to print the linked list. Okay, so let me just create and print. Let's just not find for now. Okay, so 2, then 90, then 100, and 3 and 4. This is what I should get. Okay, 2, 90, 100, 3 and 4. Okay, if I add say one more value in between, say 1 between 100 and 3, it is going to create the list in the same order. Okay, so basically creating a linked list out of these values. This is the first node, which is the head, and I'm showing this as null just to indicate that this is the end of the linked list. If I don't pass any values, okay, the list is null. Okay, going back. Okay, and then we search for say int b. Let's take b because that's what the variable stands for in our question. Searching for 100, so 100 is there. Okay, so we should be able to find 100. 100 was found. Let me make this 2, the first value. 2 was found. Let me make it 90. Okay, 90 was found. Let me make it 1. 1 is also there. 1 is found. Let me make it 3. 3 is also found. Let me make it 4. 4 is also found. Okay, for all the other values, 30 is not found in the list. Let me take one more value, say 23. Okay, 23 was not found in the linked list. Okay, if I make this null, a blank list, and then I pass values, okay, nothing will say was found in the linked list. Okay, so if I loop over say 20 values, okay, none of these will be found in this stri. Okay, commenting this. So I'm looking for values 1 to 20. So 20, nothing was found. If I create the list, say 1, 4, 18 and 90 and 100, and say 3, so 1, 4, 18 and 3 are found. So 1 was found, 3 was found, 4 was found. Okay, 1, 4, 3, 18 should also be found, and rest of them was not found. Okay, and this is your solution to part 1 of question 11. Okay, moving on to part 2, there is questions about binary tree. So I've already uploaded a video explaining each and everything about binary tree. What are the terms, what are the technical terms, what are the concepts, everything. Okay, the link for that video you can find in the description of this video. Please go through that video once and then come back and try to solve this question again. Okay, so we have 3 parts to answer about this binary tree. So this is my tree. It says part A. Name the root of the left subtree and its siblings. So left subtree is going to be this part. Let me just change the color. Okay, so this is your left subtree. Okay, this is your right subtree. Okay, you have to name the root of the left subtree is root of left subtree. Okay, what is the root? This is the root. This is where it is rooted, so it is B. And its siblings, so its siblings would be F. So siblings would be F. Okay, B part would be state the size and the depth of this right subtree. Okay, so this is your right subtree. Okay, so the first thing is size. So 1 2 3 4 nodes, number of nodes is the size. So size of right subtree is 4. Okay, and then you also have to tell the depth. So 1 and 2. Okay, 1 depth, 2 depth. Depth is 2. Okay, next is part C, where you have to find the in order traversal. In order is left subtree, root and right subtree. Okay, so you have to visit left subtree, then root, then right subtree. So it is going to be left subtree, then root A, then right subtree. Okay, all right, so this is going to be filled by left subtree. So left subtree also follows the same order: left subtree, root, right subtree. There is no right subtree here, so you go to left subtree. So left subtree, root, right subtree, if there was anyone here. So left subtree, root, so E, D. Okay, and there is nothing here, so left subtree, then B. Okay, so, and this was in the middle, and then you have to cover right subtree. So right subtree is left subtree, root, right subtree. Left subtree is C, root is F, then right subtree, then left subtree, root, right subtree, G, left subtree is not there, G is the root, and then H. So E, D, B, A, C, F, G, H is your in order traversal. So this was your solution to part 2, and all this, everything I've explained in the video where I explain you everything about binary trees. Link for that video is in the description. Please check that out. Okay, so this was the solution to question 11 part 1 and part 2, and a lot of questions based on the same pattern, question 11 of specimen papers and solved papers are already there. You can find all these videos on my channel already for the previous years as well. Okay, so this was the solution to this question. Okay, and I hope this was helpful. So if there is any doubt, there is a part you don't understand, please let me know in the comments. I always try to answer all your comments. And you can also let me know in the comments if there's a question you want to solve or the concept you want to discuss. And I solve all this on my Code with BK Hindi channel as well, where I teach in Hindi. So if you're better comfortable with Hindi, you can check out videos on that channel. Okay, so please like this video, subscribe to my channel, and thank you for watching.